Okay, well, it's 1:30, so I'm going to kick this off. So good afternoon, everyone, and thanks for joining. My name is Deborah Lawler, and I'm the federal liaison between the WestFAST and the Western States Water Council. I just need to let you know that today's webinar is recording, and it's going to be posted on the WestFAST tab found on the Western States Water Council's webpage at westernstateswater.org. This afternoon's webinar will provide attendees with an update on the NRCS's Snow Survey and Water Supply Forecasting Program, as well as the Soil Climate Analysis Network, otherwise known as SCAN. We're going to hear today from Mike Strobel. Mike is the director of the National Water and Climate Center with the USDA's NRCS in Portland, Oregon. Before I hand it over to Mike, I wanted to let you know that we will take questions at the end of today's presentation using the chat feature. You could potentially try to use the unmute, but I don't have any controls over that for you. So I do encourage you, if you have questions, to use the chat. So I guess with that, I'm turning it over to you, Mike.
Thanks, Deb. And I'll just ask anybody that's out there to put it on mute. Otherwise, we'll get feedback. And I'm hard enough to understand as it is. So the feedback doesn't make it any easier. So I appreciate that. So today I'm going to talk a little bit about the Snow Survey and Water Supply Forecasting Program. And another program I'll mention a little bit about is what we call SCAN, which is the Soil Climate Analysis Network. These are two data collection and the way of water supply forecasting activities, programs within NRCS in the Western US, and SCAN actually is across the nation. So I'll talk a little bit about that as well and give you guys a little bit of background on what we're doing and where we're heading. So next slide, please. And just so you know, Deb is going to be controlling the slides, and so I don't have control on that. So next one. Maybe. There we are. Okay. A lot of people, and especially if they're not in the Western US, ask the question about, why do we have this snow survey program and what is the utility of that? What is the purpose of it? And really in the Western US, want to back it up one, please? In the Western US, the snow survey is a high elevation system that measures the snowpack, and from that we'll develop water supply forecasts. And this history of this, and I'll talk a little bit about the history in a minute, goes back a ways. And in the Western US, the snow itself is sort of the lifeline for everything. Most of the precipitation occurs in the higher elevation mountains, and both during the wintertime, but also because of the orographic effect, as moisture moves in from the coast, that's where the moisture tends to accumulate and then melts off in the spring and summer and flows out into the basins. There can be, in fact, in some areas over an order of magnitude difference between what we're seeing in the mountains versus the basins. And most of the basins in the Western US are very dry, desert type environments. And snowpack with the snow melt really is what allows us to both populate and cultivate these areas throughout the Western US. We usually use a number, typically we have in the past, saying 50 to 80% of the annual precipitation that occurs as stream flow occurs as snow in the mountains. And that is a relative term. As you can see from the one slide here, that they have different percents for different mountain ranges. But the reality is there's some basins that have significantly more rainfall, but there's also some that have almost 100% of their annual precip is coming in as snowpack in the mountains. So it's a variation from basin to basin, as you can imagine. But generally, it's the majority, the vast majority of the annual precip comes in this form. And really, it is the only reason we can actually populate the Western US is the fact that we can utilize this water then for irrigation, but for many other purposes as well. Go to the next slide, please, Deb. And there's a lot of different uses for the information, and as I mentioned before, irrigation is one of those. But there's other areas that really are so dependent upon the information that we provide and on the snowpack itself and on the snowmelt. As we know, hydroelectric power generation, a lot of the folks that utilize our information are those who generate that energy source of hydroelectric power. And so knowing what the flows will be can help them manage then that energy distribution and what to expect for the coming year. Municipalities managing their water supplies and reservoirs. And then recreation and other sources. It's really interesting. There is, I'll leave the slide up here so you can look at some of the other information here, but it's really interesting. We did, back in 2008, we did an economic study. It's called A Measure of Snow, looking at our program. And they did a number of case studies during this economic analysis. And it's interesting to see the other utility of our information. Now, we know that how it relates to folks such as fire prediction, aquatic habitats, et cetera. But there was a couple of case examples that I thought were very interesting that have a direct business relationship. And one was a good example, one was in Idaho, where a company that does rafting trips was utilizing our information, and they saw in an upcoming year that the snowpack was very light. And they actually changed their business practices that year and saved tens or maybe more thousands of dollars on investing in smaller boats, smaller rafts for that purpose with the smaller flows. There's another example that was a case study that was in Utah where a municipality, a smaller municipality, looking at the snowpack, realized that it was a bumper year, a very large snowpack, and was concerned about flooding and worked with our local office. And they actually ended up putting in a diversion around the town and putting up some barriers to reduce the flooding. And they estimated that they saved actually millions of dollars on just these preventive measures. And so there's all these different utilities of this information besides just the irrigation part. And the irrigation is obviously critical, but the utility of this to other areas is also very, very important and has a high dollar value. And that's what this economic study found out, is that the return on what we're investing into this program is huge. And if you think about it, we cover the entire Western U.S., so the 12 states in the West plus Alaska, with the information that we provide. And we're doing this for under $10 million a year. So this program is very economical, but also very critical for what we do. Next slide, please, Ted. As I mentioned, the importance and kind of our history and why we go back to this is focused in on irrigation. And I'll wait for the next slide to come up. Hopefully it'll come up soon. The irrigation is where we take the information and distribute the flows through diversions and other aspects to various parts of the Western U.S. for purposes, back one, please. Purposes for looking at the at areas that need to be irrigated for agriculture. I'll wait for the slide to come back up, because the previous slide, please, Deb, if you can. So there's areas that you can see on the upper left there that shows where the precipitation does occur in the winter. And this is one from just Idaho, but it shows you July precipitation versus the January precipitation. And you see that it's not only orographically affected, but also seasonally affected on where we're seeing these flows coming in. And a lot of that's due to the winter storms that come in off of the coast and move in through the Western U.S. Part of it's due to the jet stream, the dip of the jet stream that occurs seasonally, dipping lower during the summer and higher in the winter, and allowing for then this precipitation to occur and less dryness. And we also can see then also from this slide here the importance of the irrigation aspect of it. You see on the left bottom corner there that out of the 10 top states for irrigation, 5 of those are in the Western U.S. So irrigation is critical and very important for our agricultural economy in the Western U.S. And looking at on the right side, we have some examples of the Colorado River in the Imperial Valley, and that's certainly one of the areas that is a high agricultural producer. And you can see on the upper slide how much of that is rainfall versus what's irrigation water from stream flow, and hugely amounts of that irrigation occurs through the stream flow distribution. And that is why it is so important for that agricultural industry. How much of that water is irrigation is important? Well, if you look at the 4.4 million acre feet that is allotted to California, 3.85 of that goes to irrigation alone. So it's a big aspect of what's coming out of the Colorado River and other areas for supporting this part of the economy. Next slide, please. And this slide, once it comes up, there's a little delay here. This slide shows you really, I use this track within our own agency to show just the critical nature of our program. These are just page views on the web pages for NRCS overall versus the National Water and Climate Center. And you can see that in general, we exceed the agency as a whole when it comes to access to the information that people are trying to get to. And it's seasonal, of course. You're going to see more of that in the winter and spring than you will in the summer and fall, when the snowpack obviously isn't there. So it is seasonal, but these web views really give us an indication of how critical this program is. We're one of the few programs within our agency that's considered mission critical. So when there is furloughs and shutdowns occurring, we still work. We always keep folks in the office, and we have operations that are 24/7, so we're considered mission critical. So it is really important. When our web pages do go down, believe me, my emails and phone is just going off like crazy, because people are trying to access this information all the time, and they want to see how it's changing all the time, which is why we put out so many different forecasts, which is why we keep things operating 24/7, because like the weather, the climate conditions, the snowpack conditions change quite often and quite rapidly. So we try to keep on top of that as best we can. Next slide, please. So some of the history of the snow survey program, hopefully it's coming up, there's always a little bit of a delay here. The history of the snow survey program goes back pretty far. We were actually started, or at least the first snow survey was started in 1906. Dr. Church out of the University of Nevada, Reno, started making snow measurements in the mountains on Mount Rose near Reno, because he had, interesting enough, he was a classics professor, not a scientist by se, but he realized that there was a relationship to the snowpack and the stream flow that occurred in the spring and summer. So he started making the measurements and trying to make that connection. And it ended up becoming a program across different states. They started making similar measurements with using the same procedures, the same protocols that he developed, and relating that to water supply, such that the sampler that he utilized and then perfected, the tube samplers that we still use today, were really developed over 100 years ago, which is interesting. So we started developing water supply forecasts even early on, and each state started doing it on their own. It became a program within our department, within our agency, beginning in 1936, but became a program with the Soil Conservation Service prior to the NRCS in 1939. So we've been doing this for a very long time. This program is one of the oldest programs within our agency. Next slide, please. So you can see that I use this slide here. This is one of our tools we call the interactive map, but I show this just to graphically give you an impression on the distribution of the information. The red points here, and I'll talk about these in more detail in a little bit, but the red points are the scan stations, and those are across the country. But you see the concentration in the western US of the darker blue and lighter blue slides or dots. Those are the manual snow courses and the SNOTEL sites. And you can see that the distribution follows the mountain ranges. I mean, that's where these sites are located. So we're collecting information in the higher elevations, and then the flow goes out into the basins. But a pretty thick distribution of information there within our program. Next slide, please. And I apologize for the delay. So there are a number of users for this information. As I mentioned, irrigation, of course, is the biggest purpose. That's our mission. But there are multiple other users for this information outside of some of the case studies I mentioned. Hydroelectric power generation, companies that use our information for that. International treaties, you think about the Columbia and the Colorado rivers both cross international borders. And so that information on stream flow and predicted stream flow through the forecast is very critical for those aspects as well. Reservoir management, working with different agencies such as the Corps and Reclamation on that. Municipal water supplies. There's other areas such as the U.S. Forest Service using this information for fire management. There's recreation such as ski resorts. There's fish habitat management. There's recreation on hiking trails. All this type of these different parts of our society and of our economy really depend on the information that we provide. Next slide, please. So this is kind of a summary slide. I'll show this up front before I get into the talk about each of the SNOTEL and the manual snow courses themselves. But just in general, the SNOTEL, which is the automated sites, those we have 873 currently throughout the 12 western states, including Alaska. Roughly half of those have soil moisture and soil temperature now. We've been expanding that aspect of it as well. So we're working on that. We have other sites called Snowlight, which are similar to SNOTEL, but they don't have the snow pillow, and I'll talk about that in a minute, but they're a lighter version. That's why we call it Snowlight. They don't have all the same sensors that we have at a SNOTEL site. Hydromet stations that just measure some of the precipitation information or other hydro information. Snow courses, which are the manual ones, and aerial markers, which we fly by or drive by, typically 1,253, but that will change year to year. And then manual precipitation. So these are ones where we actually will go out and take measurements at the site itself. So from this information, we utilize over 600 streamflow stations for water supply forecasting. These are typically USGS streamflow stations that we tie in our data with to make water supply forecasts. Over 6,700 published water supply forecasts throughout a year. We do automated models to ingest this information and track forecast trends for 322 sites. And so we provide lots of information and update it regularly. So over a year, we have 5.5 million unique page views and over almost 1 million customers reached. So it's pretty expansive program and highly utilized program. Next slide, please. And I'll talk a little bit about these in some more detail now. So the SNOTEL network is, you can see the smaller inset map there, the blue dots. Again, as I mentioned, these are the automated stations. They're across the western U.S. and into Alaska. And what we measure is snow water content, which, SWE is a term that you'll hear often, snow water equivalent, which is how much water is within the snowpack. So it's not just based on depth of the snow, it's based on the density of the snow, the weight of the snow, because how much water is there is what's really important to us, not just the depth of the snow. The depth of the snow and the density can vary highly as you move across the western U.S. We often refer to, and sometimes jokingly, but certainly skiers know this. We talk about Cascade concrete and Sierra cement. The snowpack can be very heavy, very dense, a lot of water content in it. That makes it a very firm snowpack. And then you get into the powders, the further you get into the Rockies, lighter snowpack. So it's not always just related to depth. It's also related to how much water is within that. And that's what we try to calculate. We look at precipitation, so all seasons. We don't measure it just during the winter. We'll try to measure the precipitation both throughout the year, and that's sometimes a difficult thing to do, as you can imagine, when it comes down in a solid form. Air temperature, we look at max, minimum, and average temperature, and then we measure other parameters as well, snow depth, and other parameters at each site. And I'll talk a little bit about these sites in a second. Next slide, please. And I'll mention here while we're changing slides that the reason it's telemetry is that These sites are automated sites, so we have sensors at the sites that collect the information into data loggers. And the telemetry aspect of it, for those that aren't familiar with that, means that we transmit that information, and there's different forms of telemetry, and I'll talk about that too in a little bit here, but we transmit that information then and collect it in our office in Portland, and then provide that information through the internet. So our network itself is in we say 13 Western states because we do have a few that are in the Black Hills and South Dakota. South Dakota is not considered part of our program when it comes to the operations, but we do have a couple of SNOTEL sites that are in the Black Hills and South Dakota. So 13 Western states, 873 SNOTEL sites, 42 snow light sites. And there's more than 16 million observations per year. So you think about, we transmit hourly. And so if you transmit this information hourly and you have all these sites, it's just a lot of information with lots of different sensors that we have to deal with as part of this program. It's transmitted in near real time, so every hour. So we keep that up, transmit that once every hour. And one of the reasons we've been trying to convert over, and we started in the late 70s, converting the manual snow courses to SNOTEL sites, well, the one reason is because of the immense amount of data we're getting from this. A manual snow course is where you go out with the snow tubes, and I'll show you a picture of that in a minute here, but it's where you go out and you make a manual measurement across the transect of the snow depth and the snow water. You can calculate snow water equivalent by the weight of the tube with the snow in it across this transect. And that's the limitation of your data, where when the SNOTEL site, we're actually collecting temperature and other information that is useful for looking at the climate factors and not just the snowpack itself. So a lot more information that comes out of a SNOTEL site. A lot more information when it comes to the quantity of the information. So in the course of a month, we're getting 720 transmissions versus the one measurement at a snow course. But I think one of the key factors, at least it's always been in my determination, one of the key factors is the safety factor. We do have concerns sending folks into the high elevation mountains areas during the winter when the conditions are harsh and hazardous. And so if we can automate these stations, then we reduce the concerns we have on the safety factor of it, and then go in the summer, go out to the sites and do the maintenance on the sites when it's easily accessible. And so that's one of the concerns we have, and one of the reasons that we've switched to SNOTEL at that, and just the immense amount of information we're getting. Next slide, please. And hopefully I'll come up here a second. So as I mentioned, the manual snow courses, this goes back to what Dr. Church was doing back in 1906, and he actually developed a lot of the same sampling procedures we're still using today. This is where you go up, and folks do this a lot across the West still, not just our NRCS folks, but this is truly a cooperative program where we utilize other agencies and groups to help us collect this information. State agencies, Forest Service, Reclamation, there's many different groups that help us collect this information. And this is where there's a set transect that we go back to each month at the beginning of each month and measure across the transect, depending on the length of the transect. So typically, we'll say 10 to 20 measurements across there. As you can see, somebody in the upper right corner there making one of those measurements, and he actually came in by helicopter. And where then we'll weigh, you'll drill down to where you hit the soil level, and then you weigh the snowpack that's within the tube, and from that, across that transect, we can do then calculations to measure for that location, that site, what the snow water equivalent is. So these manual snow courses, over 1,200 of these. This varies from year to year because there's some years and some months where there isn't snowpack at one of these sites. So we're not going to make a measurement at those when there's no snowpack there, or there's conditions are that we can't get into the site. There's obviously different reasons for it, but in general, that's been pretty steady. We, at one point, were only doing manual snow measurements prior to 1978 or 79. And since then, every year we've been increasing the number of SNOTEL sites, typically at the same location as a manual. And the reason for this is that you can see then a continuation of the data, so that if you put a SNOTEL site in where there was a manual measurement, then the record is not broken. And we will continue to do manual measurements for a few years after the SNOTEL site is installed as a check and balance to make sure that what we're measuring at the SNOTEL site is equivalent to what we measured with the manual snow courses. Next slide, please. And I think I just have, this one just shows you where the manual courses are. One of the things on this that's interesting, the SNOTEL sites, as I mentioned, were in the western US and Alaska. The snow courses extend, and the information that we use extends into British Columbia, so it's part of Canada as well. They also have a network similar to SNOTEL in Canada. But the measurements we use here extend into Canada, and the reason is because of the Columbia Basin. That's the headwaters for the Columbia is an important river basin in the western US, and so we utilize their information as well. The slide on the right, or the picture on the right, is just giving a little bit of information on how much this is a cooperative program. And I broke that into what are actually NRCS snow survey employees versus what are some of our cooperators and versus what are some of our field offices within NRCS and soil and water conservation districts and those that we work with. And you can see that the majority across the western US of the measurements that are made are not made by my snow survey staff. They're actually made by folks that are in cooperation with us. And most of these folks do this at no cost to us because they're doing this as shared information that has utility to them as well. So there's a lot of benefit for everybody, but this is also truly a cooperative program, which in government, that is a feather in your cap, that you can have something where everybody is contributing and everybody's benefiting, and that's a really good thing. So it's something that I like to highlight, that this isn't just my agency, this is our agencies, this is all of us working together to provide good information. Next slide, please. And I think that the next 2 or 3 slides, Deb, you can probably just go through these ones quickly. These are just some photos of some of the field work. So we have, like you see, measuring the manual snow course above. You can see some SNOTEL sites in the lower right, and the upper one there. You see some SNOTEL sites, one under snowpack itself, making measurements. Go ahead to the next slide, please, Deb. Access to these is not always easy. As you can imagine in the winter, but even in the summer, getting to some of the maintenance sites, we go in by helicopter, fixed wing plane. Some of the summer maintenance in the wilderness areas is on horsepacking trips. Sometimes we can spend up to 4 days on a horsepacking trip to do the maintenance on one SNOTEL site, which obviously adds to the cost, but it certainly adds to the adventure part of it too. Snowshoes, skis, snowmobiles. Next slide, please. The transportation aspect of it is a key part of it. It's something that for logistics is a very difficult part, but certainly makes the job even that much more interesting. And so as Deb and I were talking about this last week, and I was telling her that this is truly one of those things where you can say it's not just a job, but it's an adventure, and it truly is. I mean, some of the work that we get to do in the summer maintenance and the winter measurements is fantastic. I really enjoy that part of the job much more than I do sitting behind a desk, believe me. And it's a nice part of a nice piece of the work that certainly makes it worthwhile. Next slide, please. Okay, so this just shows you then the concentration of all the different information. This is what we call our interactive map. This is a tool that we developed a few years ago. That is a really interesting tool because it allows you to access information yourself. Instead of coming to us at the Water and Climate Center and asking for us to provide you reports, you can actually generate your own information, your own reports for any site. That and it really has a lot of utility because you can access not only present conditions, but you can get into past information. And so this tool is just, I think it's something that I'm very proud that our center had put together, because it's something that has really the basic utility for a lot of folks to utilize the information that we provide. Next slide, please. And I'll show you some of the ways that we can utilize this information once it comes up. So if you hover your mouse over a data point that we have, in this case, the SNOTEL site. You can see it brings up some basic metadata. It'll tell you about the location of the site. And again, we kind of generalize the Latin longs on these, even though we can provide that to other government agencies, we generalize this on this tool for security reasons. The fact is that you don't want folks getting into your stations that have solar panels and batteries and other type information. So those that do research, those that really need, have a necessity for accurate GPS, we can provide that. But you can see here it's more generalized, not down to the second, but down to the minute. And it gives you the information of the elevation of the site, and then you can see there's areas in the bottom there that are blue that you can click on to get other information. Next slide, please. So you can actually access a lot of information by just going to any of these sites and either hovering over it and then clicking on the site, and it'll bring up more information. So this is like, if you clicked on one of those areas down there, if you want to look at, in this case, the at the SNOTEL site itself, looking at what's currently happening both on precipitation and on the snowpack itself versus last year. You can also do this versus the 30-year normals. You can see what the trends are, and so how are we relating to the previous year or to the period of record, the 30-year normal. And it gives you information then to see how we compare to what is considered, either normal year or earlier conditions. Next slide, please. So it's a good way to visualize that easily to look at current conditions. And then we can also, on this, if you get on the interactive map, you can look at areas that will tell you, such as the colors of the dots themselves, will tell you current conditions, both in SWE, water supply forecast trends, information that's color-based. And it's interesting. One of the things that we hadn't thought of before, and we had an email just, I guess it was just a week or two ago, from somebody that was colorblind. And it's like, I didn't even consider that. And obviously I should have. So we're looking at ways that we can provide this information in a gradational zone, not just with colored base, but other information, so that those that have those visual difficulties looking at colors, that we can make something that's useful to them as well. We're working on that right now. But this, you see, the colors will give you an idea then that you can visualize across the West, or you can bring it in. You can always zoom in to look at certain areas and get an idea of what is happening now and how that compares to normal conditions. Next slide, please. So that visualization tool is really useful. Now you can do this not only for point information, but you can do this for basins. And so in this slide here, we're looking at different basins. And the colors, again, compare to either, you can look at snowpack, or you can look at precipitation, or you can look at water supply forecasts, and you can get an idea of where we're at compared to what's considered, the 30-year normal conditions. And so that's helpful for looking at areas that are maybe dry. And of course, the red area down there that you're seeing in New Mexico is in this picture is a dry area versus the darker colors, such as we see in Alaska there, where we're well above normal. So it's nice for visualizing that and using that information. A lot of the media outlets use this information then for saying, looking at and seeing what's going on at any one time during the winter, and seeing how is it, they use this to see, is this going to be, so far a dry year, a wet year. And the thing about the snowpack, as you can imagine, is even though we might be predicting a low stream flow forecast earlier in the year, these conditions can change and change very quickly. And this is especially true in the Sierras and the Cascades, where we have atmospheric rivers and other incidences that cause a high amount of precipitation occurring relatively quickly. And so that's one of the reasons we provide this information in near real time, is that it does oftentimes change very quickly, from not just month to month, but sometimes from week to week or day to day. Next slide, please. And again, this is, looking at not just the conditions on the snowpack itself, but you can look at the colored maps here with the dots to look at the estimated stream flow for certain areas as well. So like I say, I think the information is good, and you can actually bring up previous information on this map too. You don't have to look at, you can change the date, so you can look at what has occurred in the past versus now and get an information on, where we were last year at this time versus this year at this time. And you can go to the next slide. But these are just more ways to represent that information and make it usable for folks to access. And we have other products as well that we can, that are available. These map products, I think, are really great for visualizing. In this case, the one on the left is the snow water equivalent as compared to the 30-year normals. And of course, we're updating the 30-year normals now. The period that we're looking at, 1980 through 2010, will be updated. 1990 to 2020 here pretty soon. We're working on that this year. So that 30-year normal period. So we're comparing basins at any one time, and you can look at the the start of each month to look at these basin analysis to see how we're looking at compared to what's considered to be normal conditions. And so on January 1st, we were actually in the Cascades here. We were actually pretty low compared to what's considered normal conditions. And then the one on the right is point information. So the same type of information, but you can access this and you can look at snow water equivalent at each individual point at each SNOTEL station versus the percent of normal. Next slide, please. And so again, I think that to me the greatest utility of this is that you don't need to have the assistance of the folks within our center to help you get the information you need. Certainly we're available to do that. But the point is that you can access the information you want specific to the needs that you have. So you can look at a site that, a single SNOTEL site, or you can look at a single basin and find the information you need that is relevant to you and whatever purpose you might have on that, versus having us try to generate that report for you and to pull that information. And this one is, we won't linger on this one too long, but this is another tool that we provide, another product that we provide on looking at water supply forecasting, and we base this on probabilities. So as you can see, this is within a basin, so there's different points along that, within that basin, where you're looking at the stream flow, and this is going to change. We try to update these continually because the probability, the stream flow forecast is going to change as conditions change. But these are tools that are useful, and you can go to the next slide now, Deb. These are tools that are useful for us for looking at conditions and what to anticipate for purposes coming in the spring and summer. And then, of course, water supply forecast, how we use this information is we collect the data from all those points that we showed you, the SNOTEL sites and the manual snow courses, and we incorporate that information into our models. And the model we presently use is called Viper, and it's just a spreadsheet-based model that's a statistical-based model. So we're looking at comparing that conditions now to previous conditions and using that then to make estimates of the water supply forecasts. And so it's taking data, modeling it, and putting it out as our anticipated flows for irrigation and other purposes. Next slide, please. So that is a key part of what we do at the National Water and Climate Center, is providing these forecasts January through June. And as I mentioned, the main part of that information is on the snowpack itself and the water supply, or the snow water equivalent within that water. But we look at other factors such as the precipitation distribution. We look at stream flows that are presently occurring. But there's also stuff that we're trying to incorporate in now. We are incorporating in air temperature, but soil moisture, as I mentioned, about half of our sites now have soil moisture at the SNOTEL sites. And really, we're learning more and more about the impacts of soil moisture and soil temperature, but mainly soil moisture as it relates to the stream flow itself. And if you think about it, going into the fall, the amount of soil moisture that you have prior to the accumulation of snowpack is a critical factor on what's going to infiltrate versus what's going to run off. And so having that information and incorporating that into your forecasting, which is what we're working on now, is a way to incorporate that, is a physical aspect that I think will help us improve our water supply forecasts into the future. Next slide, please. So it's just, like I say, trying to incorporate all this information in a way of interpreting present conditions and how it's going to affect future flows is really a focus for our center. So other parts of our activities here, we have an electronic maintenance facility, as you can imagine, with all those stations across the West that we have to support that through our center. And so we have electronic technicians that work within our center to test and calibrate all the transducers and all the other sensors that we use, maintain and assist in our data collection and the telemetry part of it. And so this is one piece of our activities that is within the Water and Climate Center is a focus in how we support the Western program. Next slide, please. And in fact, we're just now getting that staffed up again. We had a few retirements and we're now getting our staffed up. This is a really interesting picture because we're kind of moving away from this, but not everybody's familiar with this. And I just wanted to show this because it's a really neat technology. We have, starting in the 70s, almost all of our SNOTEL sites and our scan sites use what we call meteor burst technology. And this is actually technology that developed in the 50s. The military developed it, but I think we're about the only ones who ever used it. Burlington Northern and a few other private companies use it, but I think we're the only government agency that utilized meteor burst. And what it is there's an area of dust, meteor trails 50 to 70 kilometers above the Earth's surface that we use radio waves from all of our different stations that will bounce off of this layer, and we collect that information at two master stations. One's in Boise, Idaho, and the other one is at the Dugway Proving Grounds near Salt Lake City, near Ogden, Utah. And then they'll collect this information at these master stations, and then they transmit it over the land through the web to our location in Portland, where we then provide that information on the internet. But it's really a neat technology, but we've been moving away from this. So roughly, and the reason is because nobody else uses it. So we've had to actually support the whole technology ourselves. We've had to develop improvements in this technology. We've had to invest a lot into this technology. And although it's been a very robust system for us, there's other technology that is certainly available that is more economical. So we've been converting a lot of our sites over to satellite, such as Iridium, GOES. We've been using those two, as well as cellular. And as you can imagine, if you've ever tried to make a cell phone call across the West, cell coverage is not as universal as it is in the eastern U.S. And so the cell coverage is limited, but we're presently about half of our sites now are meteor burst, and every year we're converting more and more over to satellite or to cellular. And hopefully in the next 10 years, we'll be out of the meteor burst business. But still, it's a neat picture, and it causes people to raise eyebrows. You know, do you really do that? And yeah, we do. It's kind of cool. Next slide, please, Deb. So it's nice technology. Space age, kind of sci-fi. So also, one of the things we do every year is we have our snow school that we hold that in different locations throughout the Western U.S. It's a week-long class where we teach sampling techniques, but we also teach survival techniques. As you can imagine, folks that do go up to make our measurements in hazardous conditions, we want to make sure that they can either return or can shelter down for the night, and how they can fix things such as snowmobile. There's a lot of different aspects that we cover. Wilderness first aid. This last year we didn't, but previous years we've always required folks to spend one night in a snow cave too, and that's kind of a rite of initiation into the program. Is you've spent a night in a snow cave. It's an interesting part of it, and I have folks from headquarters that don't really know much about our snow program, but do want to come to snow school, and I think they just want to have that. I remember one year, one of our chiefs that retired. I remember his retirement picture was him coming out of a snow cave, and I don't know if that's probably the only thing he had to do with our snow survey the whole time he was our chief, but it was the picture he was most proud of. I think that was really cool. But anyways, we teach this year to year. It's a great class to take, and we require it every 3 to 5 years for our staff to take a refresher class and come back to it. Next slide, please. And talk to you just a little bit about SCAN. So SCAN is not part of the SNOW survey program itself. The SNOW survey program is actually a congressional appropriation specifically for SNOW. SCAN is not a true program per se. It's something that we initiated back in 1991 as a pilot study, and the interest in it grew. We started off with 19 stations, and now we have actually about 222 stations, I believe, across the U.S., as well as Puerto Rico and the Virgin Islands. It's similar to SNOTEL in that it's an automated system. It transmits through telemetry. It collects the data. In fact, even some of the stations in the northern tier have snow pillows. But for the majority of these stations, it's looking at the focus is on the soil moisture and soil temperature, where we have sensors located at, you can go to the next slide if you want. We have sensors located at 2, 4, 8, 20, and 40 inches in depth. And we collect information on the soil moisture, so the volumetric content of the soils itself, which, as you can imagine, with the different soil types, it changes. And so at each of these sites, we actually have a snow pit where we've actually done a soil profile, soil characterization. And this is very much focused on agriculture itself. So how the conditions, local conditions, are utilized for agricultural purposes. And I relate this to what I call precision agriculture, in that those that actually utilize this information, if they have a scan site near them, can utilize the information to improve the economic costs of agriculture. And what I mean by that is that knowing the soil moisture, you can reduce, and there's been cases where they've shown vast reductions in how often they irrigate. And so the energy savings and the water savings on not irrigating when it's not necessary is critical. It helps with the soil temperature as well as soil moisture on when you can get into the fields, when you can harvest from the fields, both for planting and harvesting. Those conditions are important. When to plant, soil temperature is critical for the planting part of it. And one thing that's different than a lot of the remote sensing, the satellite-based systems that look at soil moisture, is our in situ network, with the depth we have, is actually, with those depths, we're looking at areas at and below the root zones. So that's also critical for both agriculture, both croplands as well as orchards and other types. So there are other agencies that are utilizing this information, Forest Service and others, have a strong interest in soil moisture. And this is one of the programs, one of the focuses that we have that I see will have an expansion. I think that there's a lot of interest across the country in the soil moisture, soil temperature aspects. And so we kicked this off, as I mentioned, back in '91, and I know that the Weather Service has a similar network, and together I think we have a pretty good coverage across the country of a lot of information. That, and as I mentioned earlier, our SNOTEL network has almost 460 of those sites have soil moisture. So together we have over 600-700 sites here with soil moisture. So we're doing pretty good on that distribution. Maybe not the spatial coverage we'd like to have. Obviously, that needs to be improved, but I think it's a good base to build from. Next slide, please. And at these sites, as I mentioned, we're collecting not only the soil moisture, but we're also collecting the other climatic parameters similar to SNOTEL, where we're collecting precipitation, temperature, and many of the sites were wind speed, wind direction, barometric pressure, relative humidity, solar radiation. So we're collecting lots of information at these sites. And there is the capability to add sensors on. So if there's an interest in a certain focus for an area, we can certainly do that as well. We had a workshop in January in DC on just this, on the Soil Climate Analysis Network, but also on how not just us, but all the other agencies can work together on expanding this. One of the focuses on for a lot of our agencies right now is working with a group on developing a national soil moisture network, and SCAN is one piece of that, one part of that, where we would look at not only the federal agencies, but also the state mesonets and others to develop not separate, smaller soil moisture networks, but to try to unify into a larger singular source of information for folks to use for drought assessment, for many other purposes. And so that's an ongoing activity. One of the difficulties for us right now, as you can imagine, is we have to get to these sites quite often to do maintenance. And this year has been an interesting year because the COVID-19 has impacted our field operations a lot. In fact, I just had some folks last week down in the Alabama, Georgia, South Carolina areas, and they came back with concerns about going back right now because of some of the hot spots we have with the COVID-19. So that's kind of having an impact on us right now with the work we're doing with the SCAN. And we do have a number of stations down, but we want to try to get to those and get them back up again as soon as possible. We have developed 2 manuals. One is an installation manual and one is a maintenance manual, so that not only can my center do this work, but we can actually transfer this information and others can install their own SCAN stations and have it be part of this network so that we would do the data quality and serve that information if they wish to do the installations themselves and do the maintenance themselves. Then that would be certainly a cooperative effort that we can do. We have been partnering with the Soil Survey Division, and in fact, we have brought on 2 detailees between the 2, the Soil Survey and the Snow Survey. We brought on two folks to really look at planning a strategy, a direction for where we're going to be going with this program in the future, and then also to coordinate the field maintenance and to do some of the things that many of us have not had the opportunity to focus on. These two detailees will be focusing on this over the next 120 days, and we hope to see some good results out of that. We also have somebody coming on board starting actually next week who will be working focused entirely on 100% of their time on looking at data quality for this network. And so we'll be doing data management, and that'll be really important. And then one other piece of this is what we call tribal scan, and this isn't through my center. This is Mike Wilson he's out of Lincoln, Nebraska, but through my agency, is working with BIA to put in scan stations, and I think we have now 13 or 19, I'm not sure exactly the number, but there's a number of these, what we call T-scan, that are in cooperation with some of the different reservations to install the sites where we show them how to, but they then install the site and they maintain the site. And one of the purposes of this is part of STEM, the idea that this is an educational process where they can use this for teaching folks how to collect the information, how to use the information, how to analyze the information. And so it really is a valuable tool for those that are in the sciences and engineering and mathematics for accessing information that they're actually collecting themselves. And so it's really, in that way, a really cool tool. And I think that I look forward to this one expanding as well. And we, again, can serve that information, the T-scan information, through our network, through our SCAN database. Next slide, please. And again, this is, I think the call for more information on that is far greater than our capabilities right now to train and distribute the information. But I think that the goal is to, over the next year, is to expand T-scan much more. So for our summer plans this year, as I mentioned earlier, the COVID-19 is causing some uncertainty in being able to plan for summer maintenance, both on the SNOTEL network and as the SCAN as in both. One of the things that we're dealing with, and I'm sure other agencies are dealing with this too, is how do you travel both out of state? How do you travel overnight? How do you travel per vehicle? I mean, there's a lot of things that we're trying to deal with that it's a new world out there right now for all of us. And I know that others that are managers, the information we receive, the directions that we receive, they change almost daily, it seems. And so we're really, we are on new grounds, and we're trying to adjust to that, keeping as the highest priority, as you can imagine, with all of us, the safety of our people. And so we're looking at ways to get the work done, but also do this in a manner that keeps everybody safe. So that is a concern. We do have some staff that have higher vulnerabilities than others, and so we're looking at this as best we can. And I think just like the openings, as most of us are teleworking right now, I think just like the openings of our offices, we're kind of approaching the field operations in a phased approach. So we're seeing little by little what we can expand upon. Unfortunately, I think that right now it seems like we're actually stepping backwards when it comes to the number of cases that are out there. So how this is going to impact our whole summer, how this is going to impact our capability of getting things done is yet to be seen. But we will work with it and we will manage it and find out what we can do to try to get as much done as we can, at the same time keeping everybody safe. Next slide, please, Deb. But as I say, as we're all dealing with this, that this is a new world right now, and a new way of operating that certainly isn't the same as it's been for the whole rest of my career that I've been operating networks like this. So where are we going from now? What are we doing? One of the things that we're investing heavily in, and I won't go into great detail on this, but one of the things that we are investing heavily in over the next 3 to 5 years is our IT aspects of it. And there's a number of programs that we're investing through the agency, millions of dollars, trying to improve. And one is on the data aggregation. And so this is the information, as I mentioned, telemetry. This is the information that is sent into us. And it has to come through firewalls and has to be aggregated not only from meteor burst, but from accessing information that's coming in through the GOES, through Iridium, through the cellular technologies. And how we bring that information in and process it is something that we need to update. Another thing is the data validation. So a lot of times we spend a lot of time on data quality and looking at the data. And there's two ways of doing this. There's an automated way and there's also a visual way. And so we first want to develop a tool that'll help us validate the data and help us check data that's coming in to improve the quality of that information that we not only ingest, but that we provide to the public. And so we want to make sure we catch things that are outside of that are quirks and problems. And so this first tool will help us do that. Or the second one is an editing system, the third one on the list here, where we can actually then look at the information and visualize it and compare it and edit the information so that we look for things that are outliers, things that are missing data, and areas of improving what we provide, so that as anybody that's in the sciences knows that your whole reputation, your whole quality is based on the accuracy of the data that you provide. And so we want to make sure that we provide not only timely information, but accurate information so that folks can utilize this for whatever the purposes that they have. And so we want to make sure that what we give to the public and to other agencies is correct. And so these tools are helpful in those areas. The next one is our water supply forecasting model. I mentioned earlier that we have a model called Viper that it's a spreadsheet-based statistical model. And we're looking at upgrading that. There's a lot of things that we want to incorporate into our models that we can utilize for improving our water supply forecasting. So this is an investment we're making right now on upgrading how we do our water supply forecasts. And this tool is right now being developed. And then underneath that is the product delivery. One of the things that we see going away is the FTP servers and ways that we distribute the information out to folks. And so we're looking at ways through the enterprise content management, ECM, and other interactive ways of getting information out to folks, products out to folks that they can utilize. Our system is a little bit different than a lot of systems. In fact, throughout NRCS, I think we're unique in that our system, our information is dynamic. A lot of information you look at, maps, databases, are static. I mean, they might update them on a regular basis, but they're still static. Where ours is dynamic, it's constantly changing. And so delivering this information to folks is not always easy. And so we want to modernize how we do that so that we can improve the delivery of information to those who use it. And then the last thing, I mentioned this earlier, is that we're updating the what we call the normals, that 30-year period that we compare the information to. Anybody that deals with climatic information, meteorological information, utilizes a 30-year normal. You can utilize averages, medians, but the point is that we use something as a base. And so we need to update that to shift it up to the next 30-year period. So those are things, you can go to the next slide now, Deb. So those are things that we're working on right now. We're investing a lot of our efforts, a huge amount of our efforts of the team that I have here is going into updating these IT aspects. And so that's a critical piece of our focus and certainly of the energies that we provide on a day-to-day basis. And then the next slide, whenever you're ready, Deb.
I think that's it.
I don't think so. There should be. There we go. One more slide. Good. Future directions. Oh no, yeah. I was gonna say you took away my future. Okay, future directions here. So what we're doing is a number of things, and I've kind of mentioned some of these throughout the talk. One is that we are automating these manual snow courses to SNOTEL sites. That is very much dependent on two things. It's always dependent on. I mean, there's huge number of requests and needs to update. Because people want SNOTEL sites, we want SNOTEL sites. It's based on the available personnel we have to actually do the work, and we've gone through some intense hiring lately, but it's been a while building our staff back up to help support this. And the other is it's based on budget, and like with most agencies, our budgets although they change from year to year, ours has been pretty much steady for the last few years, and so. We can invest in some upgrades, but certainly not at the level that we would like to. But that is certainly our future. We do want to expand the SCAN network. I talked about SCAN a little bit earlier. We do want to see an expansion of the SCAN network that we have, the incorporation of the National Soil Moisture Network, and then also expansion of the Tribal SCAN, T-SCAN network itself. The IT investments we're making, part of that is improving our models and how we do water supply forecasting, assessing soil moisture in the ways that we not only collect information, and of course collecting information is a strong piece of this, but it's only one part of the picture. The other is actually utilizing that information and providing models and forecasts information is really the purpose of collecting that data. And then one of the things that we're looking at too in the future, as I mentioned earlier too, that we're doing statistical-based modeling, and we're looking at simulation modeling that takes actual physical characteristics throughout the data collection areas and utilizes that then to improve our modeling capabilities. A different approach, simulation modeling with the physical base versus just the statistical modeling. And then and this is the last slide, Deb. So, but the one other thing that we're looking at, we get lots of questions too recently about the remote sensing aspect of it, where you're collecting snow depth measurements with fixed wing planes and satellites. And certainly that is an area that we are engaged with a lot of discussions and have a huge interest in what's going on with that. The question I often get is, will that replace what we do? And I can't tell you the future, but presently, no. And the idea is that you need this in situ information, you need on-the-ground data for calibrations. They actually complement each other very well. And so I don't see one replacing the other. I see them working together to only improve what we do and to provide better water supply forecasts now and into the future. So I see this as a very positive thing, and one that I look forward to with great anticipation and excitement on how this is going to make what we do even that much better. So with that, I will wrap up what I'm saying and open it up for any questions folks might have.
Great, thanks, Mike. So use your chat. I do have a chat that has come through from Tony Willardson. You could probably unmute yourself, but I don't have any control over that. So let me just read Tony's question out loud, Mike, and we'll go from there. So he says, Mike, as I recall, the annual budget has been between 9 and 12.5 million and toward the lower end for the past several years. What is the current request?
That's a good question, Tony. We haven't, the highest it's been, at least since 2007. Hey, there's Tony. The highest it's been since 2007 was $10.9 million. And then we went through that period in 2012-13 where all the agencies were going through sequestration, and it got reduced down and finally was raised back up to 9.3, I guess in 2013 or 14, and it's been steady ever since. So we're right at, 9.3, 9.4 in that range ever since that point. What's interesting right now is because of our current situation, the president's budget actually has us with an increase of 2.2 million. We're excited about that it's in the president's budget for 2021. But we also understand, as I think all of us understand, with the situation right now with the economy, with the virus and stuff, is that there's a lot of uncertainty on where we're going to be in 2021. So what's in the president's budget it came out early on before we saw these economic impacts. I can't anticipate where we'll be in 2021, but I'm hopeful that the president's budget will carry on through to Congress and that we'll see an increase. But we will work with whatever we have.
Great.
Okay, there are other questions?
Other questions out there? Yep. Any other questions out there?
You're letting me off easy. I like it.
Mike, this is Tony. Can you hear me?
I
Yes.
can, Tony.
You want to mention a little more about the work that you're doing with the National Soil Moisture Monitoring Network and how that fits with maybe work that will be involved for NOAA, NIDIS, NASA as part of that process?
Yeah, you bet. You know, NIDIS and others have a mandate to look at assessing drought, and this National Soil Moisture Network is actually part of that. So what we're doing with the National Soil Moisture Network, and we actually kicked this off in 2016 is when we started working on this. We had a meeting, a workshop, and we started kicking off. Roger Paulty and I and others started the concept of putting together a national soil moisture network that would not just be separate networks like SCAN and what the Weather Service and the state mesonets have, but really something that we bring this together. And our focus on this was that there's three pieces. The one piece is the in situ network, such as SCAN, and the climate reference network that the Weather Service has. The second piece of this is the remote sensing, both fixed wing and satellite information that collects information. Of course, we have different sources of information on that, and that's where NASA comes in on a lot of that information, as well as NOAA and others. And then the third piece of this is the modeling aspect of it. It's modeled soil moisture across the U.S. The goal on this is to incorporate in all these different pieces and all these different networks into something of a single system that then allows us to, in real time, assess across the country. And again, you can focus in on certain areas, but across the country, to focus in on the conditions, the soil moisture conditions, and as they relate to agriculture, as they relate to drought, as they relate to water supplies, and provide this information as a tool so that folks then can use this for managing their resources. So that is the goal that we presently have. We're working towards that. There's a lot of different pieces on this. It's not just us and federal agencies and not just state agencies. There's a lot of universities and even private entities that have an interest in this. So it's an exciting time, Tony. I mean, you know that talking about this with folks, it's ambitious, but I also think that it's the right direction. And I think that most folks are in agreement on that, and we're all working towards that right now.
Thanks, Mike.
Okay, I have another question coming in from Dave Shade. He asks, Do you work with Canada on the Alaska studies for the Yukon, etc.?
We don't per se out of my center. I can't speak for the NRCS in Alaska itself. The snow survey program in Alaska, it's kind of interesting. They don't do a lot of water supply forecasting. They provide a lot of information on the snow distribution, the snowpack, more closely related to concerns with things like flooding. Those types of a focus working with Canada is not something that I work with. So Dave, I can't really answer it for my center itself or for my program, but maybe the agency might have connections up from the Alaska NRCS. I'm not sure. But thank you for the question.
Another question coming in from David Levinson says SNOTEL is primarily limited to the Tahoe Basin in California. I'm curious how your staff integrates NRCS data from those sites with data from California DWR.
That's a great question. California is unique. I know that I'm not shocking anybody with that, but is unique in the snow program in that we cover all the other states for the snow data collection, the entire state portion of it. California is interesting is that they have their DWR has their own snow survey program. They have their own SNOTEL type stations. And the only rare places that we cover in California are, as you mentioned, the Tahoe Basin, but also Northern California. And the reason is because those areas, the Tahoe, which flows into the Truckee River, and of course the northern part of California, which flows into the Klamath and other drainages, move out of the state. The parts of the mountains that flow into the state, that flow and provide water supplies for the municipalities down in the western part of California, are covered by the California DWR. We do work with them. I mean, we have stations that we share in some of these areas, but for the most part, we share information so that when they collect their information, they provide it to us. You'll see in our reports, we'll show reservoir conditions and snow conditions in California, and likewise they'll utilize the information that we collect. So it's a good collaboration, but two independent groups versus how we do it across the rest of the Western U.S. But a good question, thank you.
Says thanks. Okay. Any other questions?
Sounds good then.
Oh, here comes another one. Brent Duncan. Any thoughts on future developments based on advancement of technologies?
I will tell you that Brent is the program manager for the Snow Survey program, so he's new to our program, and I truly appreciate him being part of our program now. So thank you, Brent. Yeah, there's all kinds of new technologies that we're looking at, both in the way of sensors themselves. As I mentioned before, we talked about the IT investments that we're making, and that's new technology in the modeling aspect of it. And I also mentioned the incorporation and collaboration with some of the remote sensing parts of it. The difficulty, I think, and we're always open to looking at new ways of doing things. There's some areas that I want to see more advancing than we have, such as how we collect precipitation information. I mean, we still use these towers that are fluid based, and that's not always a good situation for areas that are wilderness and remote areas. So there's areas that we want to invest in to find new sensors, new ways of collecting the information. But the other part of that is always trying to be on top of developments that are occurring that we can utilize that maybe aren't even focused on our program, but things that we can access, whether it's through NASA, whether it's through universities, that maybe have application to our program. I oftentimes tell people, that 10 or 15 years ago, I didn't know what an iPhone was, and now I can't seem to live without it. I think most people are that way. I mean, most of us that are older didn't know that we had to have this, but now if I didn't have it with me 24/7, I'd be wondering, what's going on. And so sometimes with new technology, it's that way too. I we try to keep our eye on the horizon and see what we can utilize and how it's going to improve our program. But again, that's one of these things where that vision is something that you just need to keep your eyes open for, because things develop oftentimes at a very rapid rate, and utilizing that information is something that we just need to be open to.
Any other questions?
Sounds good.
Looks like it, Mike.
Okay,
Well,
Deb, thank you for doing the slides for me. I appreciate that.
You bet. And I want to thank everyone for joining, and I especially want to thank you, Mike, for your time and your presentation today. And this will be posted on the Western States Water Council website. So
Great.
Super. Thanks. Great job.
Okay, folks, take care. Be safe.
Mm.